which sensor technologies are rising to the top and
Hmm.
are increasingly in use today versus, let's say, 5 or 10 years ago?
Sure. I would definitely say that the technology has made more leaps and bounds within the photoelectric realm. Inductive sensors have come a long way of cost reduction. So in a way, that's an advancement, but when it comes to actually having bells and whistles and feature rich type sensors, I would give that to photoelectric. Again, when I started in this industry, there was mostly AC wired relay based photoelectric sensors. So, the relay or the photoelectric sensor is tripped, it pulls in a little mechanical relay, sends an output. Now they're super small, super tiny, and DC based. They even have sensors that auto detect if it's syncing or sourcing. So that's just the guts going on underneath the hood. On the outside of things, laser technology, time of flight technology, utilizing different wavelengths of light to detect different objects. Those have all kind of evolved, and we've taken advantage of some characteristics of physics to advance the technology and to use in the day-to-day world of automation.
Yeah, I wanted to just pick a little bit more at that, and maybe you can help me understand better, since I'm just now plunging into the world of the wealth of information that I'm uncovering as I learn about sensors. So analog versus digital,
Mhm.
um, that too seems to be one of the shifts in driving the shifts in the technology. Is there a place for analog? Is there a place for digital? Where do you see this growing?
Yeah, I mean, analog's been around for a while, but what we've seen is having that be more common. Analog gives you not just is something there or not, but it gives you where is it? It gives you a value that changes with the position of the object. So it gives you a lot more data, gives you a feedback loop, if you will, that you can do something with, where discrete just gives you yes or no. So yeah, that technology, that 10 to 20 milliamp type of analog technology or 0 to 10 volts, that's there. It's growing, but we can do some of that now with time of flight measurement with lasers, where it's not necessarily an analog signal, it's an IO link value. So you're sending a value out of the sensor, not necessarily a voltage or a current to decipher with an external or third party card. So that's some of the technologies that analog technology has actually evolved into something a little more high end with stuff like time of flight.
Based on six sensors, tell me also about any technologies that used to be popular but is no longer has fallen by the way because it's been taken over by perhaps newer, more up-to-date technology. So maybe what's rising to the top now that's increasingly in use today versus 5 or 10 years ago?
Yeah. I think we're seeing a couple things. Some of the stuff is still the same. We want to look at color or contrast or marks and things like that. But how are we doing it? When SICK first started, we were doing color or like contrast mark detection for printing or vertical form fill stuff. We were doing that with a bulb, like a bulb that you would take it, screw in and screw out and put into these luminescent sensors. Okay. Now we're using LEDs, we're using lasers, we're using other things. So some of the same ways of doing things are still there. It's the technology that's kind of in them. Now everything's smaller, lower cost, lasts longer. You don't have a bulb that's burning out that costs a lot to replace. Now it's an LED that won't go bad. So we're seeing that technology shift. We're seeing a lot more distance measurement in things. So 10, 15 years ago, we had time of flight or phase correlation distance measurement. Very expensive, two, three, $4,000 for a device. So you can't use it everywhere. Now we have time of flight distance measurement in a sensor, in what would be a photo op. And we're gaining the benefits of time of flight distance measurement, meaning longer ranges, perfect background suppression. We don't really care about the color because we're timing how long light's coming back. We're putting these now into what would be photo ops. Then one of the other big things we're seeing, or I guess two other things are related, is communication. So when you've got all these eyes and ears out, you have all of these sensors. Wiring costs get really high. Just space to wire them. So IO Link came on the scene a little while ago. It's really getting a lot of traction of instead of just point to point, and relays in a box. Now we went to PLCs. Okay, so that's 1980s technology. Now even there, we can take that another level and make get more eyes and ears and sensors out there, and using IO Link as kind of a structure to bring that back in. Then you're probably still going to some sort of field bus network. But now we also, that's enabling the whole industry, IoT industry 4.0, because these sensors, even though they often are just going on, off, inside there's, oh, what's my internal temperature doing? Is the front screen dirty or not? If it's an inductive sensor, it's like, hey, I'm seeing a piece of metal go in front of me, but actually the piece of metal is at a different distance now. I'm getting a different field effect going on. That information is now available. So I'm seeing, currently using IO Link is a new thing. And I think that's going to, then the next future thing is kind of almost bypassing the field bus layer and taking this stuff up to a cloud, whether it's on premise or off premise, but really jumping into grabbing some of this data.
Tell us what role sensors play in aerospace and defense now. So contextualize that for us in today's market.
Sure. So I'd say sensors play a very important role in aerospace. All throughout modern aircraft, there are critical systems that enable safe and efficient operation of that aircraft. Now, with these systems come the need for sensors, because these sensors are essentially providing the systems and in turn the pilots with the necessary information to make decisions. So, maybe I'll give an example that we can all relate to for those of us who fly, in modern commercial aircraft. This is related mainly to cabin air pressure. Now, the air pressure in an airplane cabin is typically pressurized to about 11 to 12 psi at cruising altitude, which is similar to the air pressure at an elevation of 6,000 to 8,000 feet. So the cabins are essentially like flying pressure chambers, pumping pressurized air so passengers can breathe normally and comfortably. But in order for these air management systems to function properly, they rely on pressure sensors to enable the continuous monitoring of the air pressure throughout the flight, and can sense instantaneously if pressure is nearing dangerous levels. So the pressure sensor will send that information to the cabin pressure monitor gauge and helps the pilot or the air management system trigger an appropriate response. This is just one example, but throughout each system on an aircraft, sensors are enabling not only smooth flight, but a safe flight from takeoff to landing. And that was just one example that I give that I think people can relate to, being passengers on aircraft. But all throughout the aircraft, you have other types of sensors providing critical measurements to the systems that help keep the plane operating. So, position sensors is something that our company, excels at, which I'll maybe get into later in the interview. Temperature sensors, very important. Force sensors, speed sensors, proximity sensors, altitude sensors. These are just a handful the types of sensors sensing typically found on these aircraft systems. So it's pretty wide breadth of not only the types of sensors, but just the overall importance of them for aircraft.